If the function if f is the function defined by f of x is equal to blah, 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 at how many values of x does the graph of f have a horizontal tangent line? Ooh, okay. I mean, is this as simple as taking a derivative and setting it equal to 0? Seeing how many values of x satisfy that? What does the graph of this thing even look like? I mean, it's equal to 0 when x is equal to 0. Like, do I risk plotting this? It's an odd function also. When x approaches 0, that exponential goes to negative infinity. So, oops. So we have a horizontal tangent at the origin. It goes through the, like, how do I draw this? Okay. If I take a limit as x goes to infinity, this thing also goes to 0. It's positive for positive x. Can it have another? Well, based on, I typically don't like using the answers as a way of solving the question, the multiple choice answers. But given what the answers are, because we have a horizontal tangent at the origin, the number of horizontal tangents has to be odd because it's an odd function. So any horizontal tangent over here gives us another one over here. That is true, right? It does have a horizontal tangent here, right? It's got to. Anyway, I'm pretty sure it does, but maybe we can try and check that with computation. As I take x to infinity, this certainly goes to 0. So there's at least one horizontal tangent here. So the answer is at least 3, and it has to be odd. But given the options, the only option we have then is D, 3. Yeah, but if I wanted to show this, I guess I'd be taking derivatives and maybe we can do that. It's like a little exercise. So f of x is equal to x e to the negative x squared minus x negative 2. This is for x not equal to 0. So f prime is equal to e to the negative x squared minus x negative 2 plus x e to the negative x squared minus x negative 2 times the derivative of that exponent, which is negative 2x plus 2x to the negative 3. Let's set that equal to 0. So the exponentials are gone. I have 1 plus x make sure I did this part correctly. Derivative of the numerator, of the, not numerator, the derivative of the exponent, negative 2x plus 2x negative 3. Yeah, okay. Okay, so I'm assuming x is non-zero, so I can multiply through by x squared. So I've got here y minus 2y squared plus 2 is equal to 0. Okay, so y is equal to x squared. So we need y to be positive. We only take the positive root. And so x is equal to 1 plus, what is this? Root 17 over 4 square root plus or minus. So there are the two horizontal tangents out there and down there. And the last thing to show would be that there is a horizontal tangent at 0. Yeah, so this is just a question of computing the limit as h approaches 0 of f of h divided by h. And that's clearly, well, this is e negative, negative h squared minus h negative 2. And as h goes to 0, this goes to infinity. So I have, e to the negative infinity. So this equals 0. So this means that there is, in fact, a horizontal tangent at 0. I mean, if you're used to working with functions like this and visualizing what they look like, I mean, that's essentially how I started and more or less came to the answer. But the computations down here show directly that the answer is 3. So I have 2 horizontal tangents at these 2 points and another horizontal tangent. The derivative of f at 0 is 0. So that's another horizontal tangent. Yeah, I don't think there's anything more to this one. But if I have a mistake, I'll let you know. Thanks for watching.